Hello there, and welcome to another week's Thursday evening interview with somebody I know you're going to find absolutely fascinating. And the dog is just making a nuisance of herself. Go away, over there. Come on. Can't believe it. She waited until we came on air. I'm Anne Diamond, and it's a pleasure and privilege to be here on Viking.TV with you, wherever you are in the world at the moment. I hope you're safe and well in these extraordinary times. How are you enjoying Space Week here on Viking.TV? If you're like me, well, I can't get enough space talk. I guess those of us who lived through the momentous times of the 60s, right from the first man in orbit through the moon landings and onwards, you probably feel the same. We're very much a generation of people, aren't we, that dreamed. I know I dreamed that by now we would all be wearing silver spacesuits and, jetting off to Alpha Centauri for our holidays. I always said to my sons as they were growing up that it's a magical thing to be able to do, to go out and look up into the night sky and recognize and tell other people about the planets you can see and recognize the constellations. And do you remember once when, I think it was back in something like 2008, one of the astronauts who was doing work on the space station lost her tool bag and it went floating off into space. And astronomers on the TV that night said, actually, if you go out tonight and look up in the sky, you'll probably be able to see the space station traveling over. It'll be like a little star that's moving. And you may, if you have good enough binoculars, be able to see a tiny spot just sort of edging away from it. And that'll be the lost tool bag floating away. And so I got the kids out of bed that night and we all stood in the garden at about midnight and stared up into the sky. And we swear that we could see the space station and the little tiny dot that was the tool bag sort of scudding away. So the space program was always close to my heart, which is why when I took the family to Disney World, as I did so often, I always visited Cape Canaveral and even saw several shuttle launches and landings. So here's some pictures from the Diamond Family album. That's me at the Cape with my two oldest boys, by the way, who are now 31 and 29. And there they are again with the shuttle that's part of the exhibit. And there we were at an actual shuttle launch. The shuttle's already gone out of frame, but you can see the ascending cloud behind it. I must say the boys were a bit bored by the times I used to drag them down to the Cape, but I loved every shuttle launch. By the way, one of my sons is a physicist now and one's a design engineer. So maybe some of that sort of space stuff rubbed off on them. Anyway, they would envy me the next hour with you because my special guest today is a man who, funnily enough, his work was part of those photographs. He's an award-winning, much-honored NASA engineer, holder of the Silver Snoopy Award, which no doubt he will explain soon. He's spent most of his professional life propelling rockets and humans into space, designing their gear, being the flight controller for their spacewalks, and expanding our horizons in a very big way. And nowadays he consults on all sorts of different programs, including the design of spacesuits. He'll tell us more about that too. Despite all this, in his own blurb, he still describes himself as a geeky rocket scientist. He's Charles Armstrong, and he joins me now from his home in Park County, Colorado. Hello there, Charles, or may I call you Charlie?
Please do, please do. How are you, Anne? It's nice to be here.
Very well. It's very bleak and rainy and wet here in Britain at the moment, and we're all in sort of almost semi-lockdown. How are you? How are you faring?
Oh, we're faring very well. We've not had any adverse effects from anything. I'm up here in Colorado, and unlike where you are, it's blue skies and very dry.
Oh, but it must be cold because you've got a lovely log fire behind you.
Well, thank you. It's right now outside. It's probably about 60 degrees Fahrenheit. 20 or so maybe centigrade.
That's really hot to us Brits.
I know. But the cabin's a little cool.
How are you all faring there in the pandemic at the moment? How are you where you are?
We're fine. My wife and I both can still work from home. If you're going to have a pandemic, I guess because of the technology we have nowadays, I can even do this with you from the cabin, which I probably 2 years ago I wouldn't have been able to do because we now have the internet. But So everything's going very well. The Johnson Space Center, for instance, where I work, they've been pretty much off-site, except for the critical positions like in the control center and crew training, where those things have to be done on-site. But everybody else is pretty much remote from different places across the country because everybody can travel and do their job. About October 19th, the Johnson Space Center is going to start bringing more people back into work. A lot of the technicians in the labs will start opening back up, and they'll start phasing their reopening.
Well, that's good because there's a lot to do, isn't there? It must be fantastic for you, for instance, to be able to see that NASA is back in full business now, launching humans into space from US soil.
Oh, yes. It's very exciting because it's been 9 years since we did that. In 2011 is when the last shuttle flight flew, STS-135. And we've been working on various vehicles and contracted, the approach we're taking now for low Earth orbit, like places to the ISS, the International Space Station, is to hire commercial companies to develop rockets and let them manage the actual ascent and entry and management of those spacecraft. And hopefully that fosters a space economy. That's the idea.
Yeah.
And we get rides to space cheaper than we could do it otherwise. So we'll see how all that works out, but we'll go from there. And now NASA can focus on exploration, which is really the whole point of NASA is exploration, not day-to-day just operations.
Absolutely, and I know this is something you're very excited about at the moment. So just to get the rest of us as excited as you, let's have a look at a video that you sent me, a video from NASA that should tell us more or less what you're all working on right now. Let's have a look at this.
Okay.
That looks really exciting.
It'll be first time back to the moon in years.
Yeah, it's part of the thing I was talking about, the fact that things that we used to dream about. Can you explain what Orion is about and what Artemis is? Because I hadn't heard of Artemis before.
Okay, so there's a little bit of a history lesson. So back in about 2004 or so, it was decided that NASA should move away from things like the Space Shuttle and concentrate, which was mainly a cargo vehicle to take people and supplies to low Earth orbit. The idea was it's kind of risky vehicle that is manned. This was shortly after the Columbia accident. So they thought we really ought to get NASA out of the business of taking people along with cargo places, because you can take cargo with unmanned vehicles. So we completed the space station with the shuttle because it required the shuttle to build the space station. And then once that was complete, then let's focus on exploration, things that people do very well, and we can design systems around that. So they created the Constellation program. Now, that consisted of what we now know as the Orion spacecraft, which is the piece that carries the people. It's a transportation vehicle, a big rocket that's now called the Space Launch System, and then the ground infrastructure that's required everywhere. So that program, as a program, got canceled in 2010, and that's a story in itself.
Yeah.
But Congress decided that it liked those three pieces, and no matter what you were going to do in space, you needed those three pieces: a way for people to get to space, a big rocket, and the ground infrastructure. So they funded all that. We've been I'm going to say it this way, we've been kind of languishing around for several years with a goal. Finally, about a year and a half ago, the president decided we're going to go back to the moon and we're going to call this thing Artemis, which, okay, Apollo, his twin was Artemis. Now, so they decided to call the new program Artemis, and it captures those three elements: Orion, Space Launch System, the ground systems, and a new piece called the Gateway. Okay, we'll talk about that in a minute. So the idea is that we were supposed to put boots on the moon, first woman and next man on the moon by 2024, probably summer of 2024. And it'll take us 3 missions. That video was of the first one, Artemis 1. Which is an unmanned mission. It'll be about 3 weeks long, goes in the vicinity of the moon, goes further out from the moon than we've ever been before with a manned spacecraft. It will be an unmanned mission, though. Okay, it's mainly just to test. It'll be the first flight of the rocket and the first flight with Orion on that rocket. So we want to make sure they work and play well together before you put people on board and count on them in their entirety. Then there will be Artemis 2. That'll be basically, I think this concept is still the same. These things change over time. But that Artemis 2 will be the same kind of mission, except with people on board for 3 weeks, living and doing their thing inside the Orion spacecraft, making sure the life support all works and everything else that they're going to need for the mission. And then in parallel with all that, NASA is contracting with a couple of vendors to produce landing systems. Okay, like the LEM was for Apollo, we need some kind of landing system. And that'll be a commercial vehicle. And we will buy these things from the commercial vendors and use them. And they're supposed to fly theirs up to the moon, in the vicinity of the moon, in 2024. We will meet it with the Orion. There will be a little transfer vehicle that they'll get in the right orbit and everything. And then we will land on the moon in 2024, third mission.
And you've sent me some of the lunar art that is being produced at the moment to show what it might look like. And I'm just so thrilled that this could now happen again in my lifetime.
Yes.
Isn't that brilliant?
And mine, I started working at NASA in 1979, and the idea was we were going to do this space station and shuttle thing for a few years, and then we'd go back to the moon and on to Mars and all that kind of stuff. So a lot of us of my generation at NASA say we've been going around in circles for a long time, and it's like, and we've been wanting to go back out again. So now we're finally going to go back out again, and hopefully I'll still be a part of it a little bit.
Oh, exactly. Watching.
And this, what's exciting now is the moon is different than the moon that Neil Armstrong landed on, and I'm not related, Uncle Neil, but because we've always thought of the moon as being a cold or hot, barren place. Well, in the last 10 or so years, we discovered that there's a very high likelihood that there is water, frozen water at the South Pole of the moon. And so the idea of this first landing may be someplace in the equatorial region of the moon, because it's probably easier to get to, right away. And this is what the Gateway can be used for. It's like a little space station that'll be in orbit around the moon, in a special orbit that you can access any point on the moon you want, depending on the timing and all this. So the astronauts would go up to the Gateway, occupy it, do some observational things, research, whatever. And then at the right time, they would take the lander down and land at the South Pole, where we'd like to establish a moon base. Yeah. And I'll say it this way, mine the water that's at the South Pole. And the reason why water is important, and this is important for the moon, it's important for Mars, it's important wherever we want to go in space, is because water is very important, as you know, to life. I like water. Water's good. So, and if you don't have water where you're going, you have to haul it with you. And the hardest thing to do in space exploration is get stuff off the ground. So the lighter we can make everything, the better off we are. So if we have the water we need on the moon, that's a big advantage.
Because there were two schools of thought at one time, weren't there, of space exploration from a space station and space exploration having gone to the moon and created a base on the moon. You're clearly of that persuasion.
Yes.
You need to get to the moon first.
Yeah. There's also the schools of thought dealing with, oh, we've already been to the moon, we should just go straight to Mars. Well, that's
a long way.
It's a very difficult thing to go to Mars. I mean, it's difficult going to the moon. Make no mistake about that. But it's much harder going to Mars. It's a lot further away. If you're going to, you have technologies we need to develop to live on Mars. And gee, we have this planetoid, if you will, another celestial body that we could live on that's only 3 days away in a rocket versus 6 to 18 months away like Mars. So if you have a problem, you just kind of shoot for the big blue dot in the sky, as opposed to Mars. You get to Mars, you have to wait till the right time or else you could die on the way back. And it's a big problem.
I find it absolutely spine-tingling talking to you about that. I mean, you know so much about all of this, the history of it, and you've been there and you've been in it. Do you ever pinch yourself and think, gosh, when I was at high school, I would never have thought I could be here?
Probably my pinching days are over, but because I'm used to it now. But I'll tell you what, when I first started at NASA, I couldn't believe they were paying me money to do it. I have to say that, because who does this? I mean,
We have photographic evidence, do we not, from an old newspaper?
I guess.
That showed, real promise at an early age. This looks like something you won at school, or there was a reason that they reported on you in the newspaper.
So I'm from Springfield, Missouri, and this is from the Springfield News Leader back about 1974, I guess. And so they just had a reporter that did his explanation was at the time, and it's still kind of true today, teenagers get a lot of bad raps, for a lot of things. And he was trying to feature teenagers that, were doing well academically and doing things and had aspirations for things and whatever, the hope of the future, I guess, And so I don't know how he ran across me, but I got a phone call one day from this guy, and he wanted to do an article about me and what I wanted to do when I grew up, kind of thing. And I have to go. I haven't looked at that article in a long time. I don't know what I told him exactly, but one of my big hobbies was astronomy, and that's me and my telescope.
Yeah.
And I still have that telescope here at the cabin, because in Houston you can see 4 stars on a good day, but at the cabin on a good night it's brilliant outside. But so that's me and my little telescope that I mowed lawns for.
At the beginning, there's nothing cooler than a guy who can point up at the stars and tell you what's up. I've always told.
Well, I don't know about cooler, but nerdy anyway.
I know it's sexist to say it, but I've always told my sons, if you can tell a girl, what constellations you're looking at, she will love you forever. We've also got a lovely picture of you when you graduated. Very, very proud moment, I can imagine. That was a Bachelor of Science degree, I presume.
Yes, I have a master's. I have one of those too, but this is I graduated from Southwest Missouri State, which is now Missouri State University, and I graduated with a degree in physics and mathematics, double majored, because if you take all the math, you can, for physics, you almost have a major. And then I minored in astronomy, and my goal at that point was to go off and become the third, I have to say this carefully, the third great astronomer from Southwest Missouri. So I have a friend that says I say that sometimes too fast. It sounds like the third great astronomer.
I see.
The first 2 astronomers, one I know everybody's heard of, that's Edwin Hubble. He's from Marshfield, Missouri. They have a statue of the Hubble Space Telescope in their town square. The second one is a lesser known, but in astronomical circles, very well known, Harlow Shapley. And they're kind of related in their research. And in fact, Hubble disproved something that Shapley was trying to prove. And all this. But Shapley was the director of the Harvard Observatory in Mount Palomar, I believe, for a while. But anyway, so I wanted to be an astronomer. What's that? I'm sorry?
There must be something in the local water or something that produces.
Maybe. We had dark skies. I think that helps. Now I didn't know. I had a car dealership that was like 3 blocks away, and I had to wait until they turned off all their parking lot lights at night. And the dog and I would go in the backyard then, and I could see the southern sky pretty well, but Friendly Ford was blasting out the the northern sky.
So there you are, a very young, precocious talent by the sound of it, and you got your job at NASA. How did that start? What was your first job at NASA? What did you have to do?
Oh, that's where I was doing the pinching. Okay, this is me in the Skylab mock-up. I was a summer intern at NASA the summer of 1979. And that was the summer of what we lovingly called Splatdown for Skylab, because the Skylab had been in orbit since, I should know this, mid-70s. Okay. Yeah. And the idea was eventually the shuttle would hopefully get there in time and be able to save the thing. And the shuttle slipped well beyond when it had to deorbit, and so they couldn't save it. So it re-entered that summer. But they had a mock-up for when they trained for the Skylab missions, and that's just a picture of me in that mock-up, and I thought that was pretty cool. But I was a summer intern, and one of the reasons I got selected for the job was because on my application they have a space that says, other things you do, and one of them was, and people that from our era may know this, but new people wouldn't. I knew something about assembler language, a computer programming kind of a language that called PAL 8. And it turns out that you think about NASA guys in the 60s, you think they were all about computers and things. Well, they weren't. They had a mainframe computer that controlled everything and gave them data and all this. But they were still slide rules and paper for most of them. And so, when I showed up, I was the new kid that knew something about these computer things. Okay. And I knew something about the language, and this was important because when I got the phone call from NASA, would you like to come and be a summer intern this summer? They say, we have this brand new spacesuit. We call it the Extravehicular Mobility Unit. And for short, we call that the EMU. But that is the big, iconic white spacesuit that everybody sees on a spacewalk. Big, bulky, looks like a Michelin Man. And it's got a little computer inside of it that monitors everything going on with the backpack and the conditions of the astronaut. And we need some help with that. And I'm like, sure, I'll be happy to help with that, And it turns out they had a simulator that had been provided. And they said, so figure out how this thing works. And then we need to write procedures for everything that could go wrong and what we're going to do about it. And I'm sitting there going, weeks earlier, literally, as this was approaching, I'm sitting around in the physics department at good old Southwest Missouri State, and I'm talking to my buddies, and we're just talking about, well, what would you do if you ever had a hole in your suit? I was the guy figuring out what you did with a hole in your suit. I'm like, I'm getting paid for this. We were just having, we were just sitting around kind of BSing in the hall, and we would have done it for free.
To be given the chance of doing that, and to go there and to meet the people. There's a lovely picture I think we've got of you with somebody I do know very much from all the movies I've watched, I suppose, Gene Kranz. What were you doing there?
That's the worst day of my life right there.
How come this is the worst day of your life?
Well, okay, this gives a little background on how a spacesuit works. So this was STS-5, and this is inside the Mission Control Center, as you can see. And we're not having a good day because this was the first time we were going to try to perform a spacewalk, an EVA, extravehicular activity.
Yeah.
And so we had Joe Allen and Bill Lenore in the airlock in their EMUs, or getting in their EMUs. Joe turns on his fan, and something we'd never seen on the ground happened. And I'm sitting there in the control center, and we're watching the amps on the power supply go up and down, and then just crater the power supply. And we're like, what the heck was that? And we had no idea. Nobody had any idea what was going on. All we could figure out is something's wrong with the fan. And I didn't know. And I'm sitting there. I'm a brand new flight controller. This is like my second time in the control room. One of the things normally when you're a flight controller is you spend many, many hours in the control room in simulations. EVA was kind of a queer duck in terms of we never got any data on the ground. All those flight controllers you see in the mission control, they get scads of data from the electrical system, environmental control system, the radios, the navigation and control, everything, propulsion, whatever. They got lots of data. They can tell you what's this going on, that going on, all this. All I had was a little piece of data about an airlock power supply, nothing coming from the EMU itself, the spacesuit. And this has never been seen before. I'm just making like every mistake possible in the book that a rookie flight controller can make. The flight director is Tommy Holloway there, and this is back before we had constant satellite coverage. So we would come back to we have like 2 minutes of acquisition of signal where you actually could talk to the spacecraft. And so while you're not talking, you're supposed to be figuring out things so that they're ready to go the next time they could talk to the spacecraft. And he's just hammering on me. Well. So
Charlie, how old are you in that
23, 24 maybe, you know, and that's a typical flight controller age. I mean, you know, but it's kind of, but they'd only had one EVA sim in history at that point. And this EMU is actually fairly simple in a lot of ways from a redundancy standpoint. I mean, the shuttle, I mean, you had 5 main computers on the thing, GPCs they call them, general purpose computers. And you had to manage your redundancy. And they had all these failed, you know, modes on everything. We didn't have any failed modes. The fan doesn't work on the EMU, you come back in. Well, we were thinking it's just going to fail because we're just ignorant. And I didn't have the experience, and nobody around me had the experience to know I had to think a little deeper about all these things. What happened was Crans decided, since we were just flailing in the room there, and in the control center, the front room are all, I'll call them management positions mainly. And then you have more technical experts in back rooms in the same building, and we all communicate on those little headsets. Well, Crans decided, you know, take out everybody except for me, because somebody had to talk to the flight director, and meet in a meeting room called the Action Center. Everybody I was talking to that knew anything besides me left, and I was sitting there all by myself and I had no idea what was going on. And the flight director is beating on me. When are we going to know something? I'm like, you know? And then we come back and say, okay, what we're going to do is we're going to try some tests with the fan. And what that picture is Bill Fisher, Anna Fisher's ex-husband, who also was an astronaut, is sitting in there, and he was back in the Action Center, so he had just brought out what the plan was going to be. And the plan was to try some stuff with the fan and see if we could get Joe's fan to work, and if not, what we're going to do is we're going to take Bill to vacuum in his suit, and we'll just stay in the airlock and not go out, because we always like to have a buddy system when you're doing an EVA. It's kind of like scuba diving. You have a buddy. So we're going to do that. Well, we did our little test. It didn't work. We got Joe in his suit out of the airlock. Bill goes to do his leak check for depressurizing the airlock, and his suit regulator for his oxygen system, it's supposed to be at 4.3 psi, pounds per square inch. Mm-hmm. It comes up 3.8 psi. And that's a significant number because we have, as part of the only redundancy in the EMU, is a secondary oxygen system, an emergency blowdown bottle, basically. And it regulates at what pressure? 3.8 psi. And we had a rule that said if we're on the SOP, the secondary oxygen package, this emergency oxygen, you can't go EVA, or if you're EVA, you have to come back in. We couldn't tell if we were using it or not because we didn't have a sensor on the system. There's so many things that were wrong in that picture. And so all of a sudden now we have no EVA capability. So I'm like,
You described that as the worst day of your life. How long was that day? How long did that all go on for?
It seemed like 3 days. This is kind of funny too. So I'm real excited. You know, when this is starting, I'm living the dream, man. I'm going into the control center, front room. When I enter the control center, I can see this like it was yesterday because this was very exciting. I am high on life. I am ready to roll. This is going to be a great day. You know, I'm in the control. I am in the middle of the space program.
Yes.
My gosh. How exciting can that be? I go in the control center and they've got a payload bay camera on the Earth that's on the big screen. And it's kind of like you're looking out the window of the space shuttle. And I'm sitting there going, how cool is this? And I had already told my mom, just the way the timing worked out, we were supposed to be going EVA, leaving the hatch about the same time the Today Show came on in America. And I'm telling my mom and dad, tune into the Today Show. And I arrive at the MCC at about 3-4 o'clock in the morning, and we're getting the preps we're supposed to have the preps done, and we'll be exiting the hatch a few hours later and all this kind of stuff. When it was over, the sun was just coming up.
Ooh.
Oh my God. I'm like, it's not even 9 o'clock in the morning yet. I think it was like the Today Show was just coming on when I was going off console. It was awful.
Yeah, it's a reminder.
So long.
I just can't get over the fact that you're so young, and that even at that young age, and because you're a parent of somebody of a similar age now, aren't you? You're that young, and what a huge responsibility.
Yeah. Well, the guys that landed people on the moon, they were all in their mid-20s. Flight directors might have been 30. They were the old guys in the room. But, Gene Kranz, when he was flight director on Apollo 11 or Apollo 13, he was in his 30s, and all the guys working for him. Steve Bales, who was the guy who really gave the goes for landing on the moon, he was like 27 years old.
Let's have another look at that. Let's have another look at that picture before we let it go, because I think it's quite historic. Tell everybody at home where you are. Gene Kranz is the one in the middle with the waistcoat on, because he was very famous for his waistcoat.
Oh, yes. I'm, of course, the young kid on the right-hand side there in the suit.
Yeah, in the dark suit. Yeah.
Okay, the guy on to my kind of bottom left-hand side there is Tommy Holloway. He's the flight director.
Yeah.
Bill Fisher's next to him. And he's talking to a gray-haired guy named Hank Hartsfield, another astronaut. Then there's, of course, Mr. Kranz to my right, looking down at what Bill's talking about.
Flight controller.
Yeah. Next to him is a man named Dick Thorson. He was a flight controller. He actually ran what's called the SPAN, or what do we call it? System Planning and Analysis Room. And then Dave Walker, another astronaut. Yeah. Behind Dave Walker is Bob Stewart, who ended up going EVA on 41B and flying the MMU. But
that is quite a photograph.
And yes, I mean, that's okay. So we talked about a little bit of the good stuff with NASA. So the bad part is there are people around taking pictures of you on your worst day.
Yeah.
Just to remind you.
Thank goodness.
Yeah.
What I also find so interesting about your career is that you didn't just sit behind a computer screen or with a ruler thing. What do you call it? A slide rule.
Slide rule.
Yeah.
We had calculators by my day.
No, who knew slide rules would go out of fashion? But you were clearly you were very much part of the astronaut program. You got yourself really involved. You even got onto the Vomit Comet. Which,
oh yeah. One of the great things about EVA was you did everything except fly the mission. Okay, because mission operations was different back then, where they had training and flight control and all these things separated out. EVA did it all because we were a very small group. So we were one-on-one with the astronauts. We trained them personally. We wrote all the procedures ourselves. We did all this other stuff. And then when it was time to fly the mission, we went to the control center. Mm. But there are several facilities we use. One of those is the Vomit Comet there. This is just a standalone thing. That's Bruce McCandless, father of the Man Maneuvering Unit. Yeah, and we were actually getting ready for a flight after his flight. He flew on 41B, which was a test flight for the Man Maneuvering Unit. And then the following flight was 41C, which was the Solar Maximum Mission Repair Mission. And this is a box, an electronic box that was going to be repaired. And it required some special tools because it was not designed to be repaired by an EVA crewman. And you've got to worry about little screws flying away.
Yeah. And
all sorts of little pieces like that. So that's a special screwdriver that actually Bruce designed. It's got a big handle on it because you have these big gloves on when you're EVA and very little dexterity. So you've got to have big clunky tool handles and things like that. And this had a little capture device, and these were going to be little bitty screws that were of a classic D connector that you see on a lot of electronics. It's kind of like a serial data port connector, and try to capture these little screws as they came off and not have them float away. And he had a little pouch that you'd stick them down into, and they stay in the pouch. But so that's, of course, me on the right-hand side.
Oh, I can recognize you now.
Oh, yeah.
Was I right about when I mentioned earlier there was that EVA where one of the astronauts lost her tool bag and it went floating away?
It happens. It's not good to happen, but it happens.
But it happens, and these things happen, I suppose.
Yeah.
But you did some training as well. I guess if you're in designing all of these things, you have to actually wear the spacesuit yourself and try and figure out what is different about maneuverability and things like that.
Yeah, in fact, it's a lot better than it used to be. It used to be there were a lot of rules about who would get into the water tank and who would be able to get in the suit and all this kind of stuff. And that's gotten, for a lot of good reasons, has gotten loosened up in the last several years. But the previous picture you saw, that is actually the astronauts, George Nelson and Ox Van Hoften, repairing the box that we just saw Bruce and I working on the ground. And that was on 41C. That was also another interesting mission for a lot of reasons. But it didn't go quite right and had to do a lot of real-time rethinking about things. But yeah, so we got to do a lot of the same things that the astronauts did, or at least we were hanging there with them while they were doing it and telling us about it.
Which of course begs the question that Joe from Dallas in Texas, hi there, Joe, has already emailed in. He said, "Did you ever want to be an astronaut?"
Yes, when I was growing up. But as you saw in that previous picture, I had these really Coke bottle-y glasses for a long time. I got lased a few years ago, so I can actually see now. But but yeah, so my vision was never that good that I could have been an astronaut for one thing, And then, yeah, I probably didn't have the rest of the background, maybe, but it's a possibility, and things change over time. But yes, it would have been fun. But the astronauts kind of come and go in the program. Now, some come and they stick around forever and they retire from NASA. A lot come in they fly once or twice and then they move on to something else because they're high performing people and they do a lot of things and all that. But so I stuck it out for 35 years. Yeah,
35 years.
And got to do a lot of fun things. So
it's impossible to cut a long career short. But let me move on to when you actually ended up working with the Russians. Okay. Do you speak Russian?
No, yet.
Good.
No, but we had interpreters.
Obviously, you collaborated with the Russians. There you are. I think is that Mir control?
That's the same mission control center we were in for STS-5. And this is skipping ahead. This is probably STS-71, as I recall, the first rendezvous and docking with the space station Mir. We had a program kind of leading us into what now is the ISS called Shuttle-Mir, or if you're in Russia, it was called Mir Shuttle. And the Mir space station, of course, was a Russian space station. It had been up there for many years and performed well. And as part of the whole, wall falling, no longer Soviet Union, and in an effort to keep the Russians from selling missile technology to Iran, we said we would pay you what Iran will pay you for the missile technology if you'll do some joint ventures with us. So, and this was kind of to expand on what had happened way back in Apollo for Apollo-Soyuz, where we had the first big handshake in space between the Soviet Union and the Americans. And so the idea was, and the Russians were really keen on doing this, and to actually, whatever we did, if you could come up with a reference that was back in Apollo-Soyuz, they were like, let's do it that way, So there's a lot of looking up stuff in books about how they did things in Apollo-Soyuz. But we started working with them. We would fly our astronauts to the Mir space station. We also, because we had the cargo capability, carry supplies for the Russians up to the space station. They really liked that. At the same time, we would fly cosmonauts on the space shuttle for different missions. And so that was being worked out. And so when we were having these joint missions, this is a picture of the Soyuz spacecraft.
Yeah.
Okay, so that's what the Russians fly. And this is how until the SpaceX vehicle, the Dragon, came along few weeks ago. This is the only way anybody could get to the space station. We buy rides on that. But so we had these joint missions, and our astronauts would live aboard the Mir space station for months at a time, and then we'd come pick them up with the shuttle.
It got to be very old and a bit rattly, didn't it? The Mir space station.
Oh yes, and it had some issues along the way that were very scary for a lot of people. My job was I was what they call a Russian interface operator, and I had a couple roles in that. The key one was to be the liaison between the two control centers. I had a counterpart in Russian, the assistant flight director, the SRP, and we would do all the coordination, and we would report to our respective flight directors about what's going on the other side. That way they could be monitoring their own vehicles and that kind of thing. And so we were kind of like right in the middle. And I also, with another counterpart in Russia, wrote the joint procedures that both the cosmonauts and the astronauts would use during the joint missions. So we were over in Russia a lot, and they were over here a lot in America. And one of the times that we were in Russia was when Mike Foale was on board. And that's me in the Soyuz mock-up in Star City. And my counterpart, Victor Svirin, is on the side there. He actually worked Apollo Soyuz. He passed away a couple of years ago, sadly, but he was a great guy. And he gave me all of his Apollo Soyuz books. What's that?
Mike Foale was a Brit.
Yes.
I remember being on a radio station at the time, and we were all worried about him, and we were all talking about him because we were terribly excited. And I used to regularly speak to his parents every morning on my radio station.
Wow.
It was really, really exciting then.
Yeah, he goes to my church.
He used to talk a lot about how rattly and decrepit the Mir space station was at the time, and they were very worried for their lives at times.
Oh,
but
yeah.
there you go. It's just part of an era.
What was interesting, we were at after they delivered Mike to the space station, they had, this is back in the good old days when we had parties and things. And so there was a party after the mission was over, and everybody who supported the mission goes to the party, all this kind of stuff. Well, the Mir was flying over when we were at this party, and so everybody went outside to go see it. And my kids are there, and I remember my son, who's this little guy, he knew the Foles kids from church, and I go, Mr. Foles on that up there. And he looks at it going, no, he's not. I mean, because to him, he was just a little dot. He didn't have appreciation that it's a spacecraft. It's just a little light in the sky going over there. How would Mr. Foles be on that little light? But anyway, that's kind of funny. But I was over in the control center when they performed a docking test with they were trying to do a manual controlled docking of the Progress cargo vehicle with the Mir space station. And so the commander of the Mir was trying to drive this thing in, and it had problems that were going. There are several books around that go into great detail, and Mike does a very good job of explaining the whole thing himself in some videos. But basically the spacecraft smacked into one of the modules of the Mir and caused a massive leak. And so I'm in the control center over there watching all this. They invited us, oh yeah, come to the control center. I'm in the Moscow control center. All of a sudden, I'm hearing, you just asked if I understood Russian. I know a few words of procedural Russian, I'll say that, okay, because I helped write the procedures, and so I know when they're talking about hatches and latches and things like that. And I'm hearing these words, and we're sitting with an interpreter, and I'm like punching, going, what are they talking about? They're talking about pressure, and they're talking about hatches, and I'm hearing latches. So what are they saying? And I'm also sitting there with one of our flight directors, and we're all like looking at it. It's like something about pressures and closing hatches and things like that. And I turned to Paul Dye, who's the flight director, and I go, I think they smacked, into the thing, and all of a sudden we're like getting up, and he's going out to go talk to their flight director and going, what the heck? Because we're hearing yelling. They have a balcony over their main control room. We have a big glassed-in room for an observation thing an hour, so you don't hear what's going on. But we're hearing a lot of yelling across the room downstairs. So yeah, they almost cratered their spacecraft, and Mike was instrumental in fixing the whole thing. So because it lost power, and they had to get attitude control back, and it was just a mess. They almost had to bail out of the space station, but.
And talk disasters, of course, then came Columbia. And you played a very big part, I think, in the recovery operation.
I personally wouldn't say I had a big part. I had a part, and there were a lot of people that did a lot of work on that. It was, everybody I worked with, we said it was some of the best, most rewarding work we ever did, except for the reason we were there.
Yeah.
This is, of course, the first picture was a picture taken over Dallas of the disintegrating orbiter. One of my jobs I did what I called 2 tours of about 2 weeks each, supporting the recovery effort. This little montage here is we were out of Joint Air Station Dallas, up, and we were kind of part of what I call the western frontier of where debris may have fallen, and a lot of the big pieces fell in the eastern part. You hear a lot about East Texas and that kind of thing, and that's sadly where the crew was recovered. But the forensics were all going to come out of our area, because the first pieces to come off were going to tell you where did the problem happen. And so in West Texas, I think it was West Texas, is where they found a piece that they found that came off a tile on the left wing near the leading edge. And that kind of thing. But that kind of thing. And so what we did is we had to set up a kind of command and control center, a little mission control, if you will. As one of my bosses once said, is an operator is an operator. If you can operate in the control center, you can operate anywhere. So I set up the process. You saw that room there with all the people in it.
Yes.
We have a screen in the front with the big map that projected, showing the debris trail. Every piece of debris was mapped with the GPS. GPS was brand new back then, so everybody had these little Garmins running around, and you'd find a piece of debris and you plot it using the GPS, and you bring that information back, and we plot it on the big screen so you could see where you wanted to go search. And then we had a phone center so people could call in. I have some piece of metal in my backyard. There's a picture of me sitting on a helicopter there, I think, or there's maybe one coming up, where I'm talking to Jerry Ross on the phone. He's an astronaut. There I am. I'm on the phone. That's our helicopter. This was when I was in Corsicana. We had to do the same thing. They decided to move the center of our operation to Corsicana, Texas. And I had a helicopter I managed there, and we were trying to figure out where to go. And these people had called us out near, oh gosh, I can't remember now. Anyway, it's west of Dallas, near Weatherford, and they thought they had some debris that had fallen on their ranch, and so we took the helicopter out to go pick it up and all that.
Well, yeah, because CSI, every little tiny piece of debris,
right? And they took all this, they took all this debris to the Cape, and then they had a big hangar there off of the main shuttle runway, and they laid it all out in a big map. And figured out, okay, we're missing these pieces here, so something happened over there, because what you didn't get back, it probably burned up because of the heat of reentry. But
tell you what, I mean, I know that we asked you if you ever wanted to be an astronaut, but it's at moments like that you must have gone home and hugged your wife and children.
Well, yeah. In fact, what was kind of even a little closer to home was I was supposed to go back for a third tour, and they had more helicopter operations that they wanted me to conduct in the eastern part. They were beginning to close down the Corsicana stuff, and they still had a bunch of stuff going on in the eastern part. And holy moly, that's where during that tour that I ended up not going on, they had a helicopter accident, and several people were killed in that helicopter accident. Like I said, I went to go, that could have been me. I mean, that's probably the closest I thought about. That could have been me on that. But that was very sad. It kind of compounded the whole tragedy of everything that had already happened.
But I mean, all of your work went into the recovery program, the return to flight program, and eventually things did get back, and we did astronauts into space again, and look where we are now. To whiz right forward, because we're running out of time. I can't believe I could talk tonight. What about looking to the future plans for space travel? I know these are the very things you love to talk about. For instance, what we're looking at now, what is that?
Oh, that's just a graphic showing kind of the overarching plan that NASA envisions for how to approach exploring the universe, if you will. If you look, you have the Earth on the left-hand side, then you have this one arc that shows like the space station. So that is representing the things we've been doing, whereas mainly in low Earth orbit. And then the next iteration out, you see the moon. And that requires something like the SLS and Orion. Okay. Those things are still required when you go to the next iteration out, which is Mars. Okay. So this is an expanding view of how we approach space exploration. You kind of, let's go there, let's make it an operational piece of our universe, if you will, and then we'll move on to the next part. And then, for the deep space stuff, you see things like the James Webb Telescope and the Hubble Space Telescope and things like that out there, because we will long be gone probably before anybody goes out there. Unless there's warp drive, and then, all bets are off. Captain Kirk. Yeah.
But Mars, do you think Mars in yours and my lifetime?
Budget. The biggest problem between here and there is budget, and that's the thing that rockets are made of. I mean, it really comes down to that. If anything we want to do in space is going to come down to spending the money to actually and having the motivation to get it done.
Because the brains are already there, aren't they?
Yeah, we can, because, we can imagine doing things and we can do them.
President Kennedy was able to sort of look 10 years in the future and say, we will get to the moon. So if we had the willingness and if we had the budget, and maybe if we had a space race again, we could do Mars. Do we have a space race now? You can almost tell that the US would like to get there before anyone else, wouldn't they?
That's a hard thing. Yes and no, we have a space race. It's one of those things where, at least in the United States, the Chinese space program, for instance, I think is way underreported. There's a lot of things that even when I go and look, I'm surprised at what they've been doing that I haven't heard of. About, was it a year ago when they landed, they had a lander that went to the south pole of the moon and a little bit behind the moon. And that was a very advanced technological feat. Other people have tried. It's hard to land on the moon. We've done it. NASA has several times, different vehicles. The Israelis tried and they came really darn close. But space is very unforgiving. If you get close, you're still going to have a problem. You're going to die, but the Chinese were able to land their spacecraft on the far side of the moon near the South Pole and drive. And they have a little rover, and they have and the reason they can communicate with it, they have a little communication satellite goes around the moon. They've had a space station. We don't know about. If you saw the movie Gravity, with Sandra Bullock, they talk about the Chinese space station. I bet to a lot of people they didn't realize thought that was just part of the science fiction part that they have. But they had one, for a while. I think it deorbited, and now just the little articles I see here and there.
The Chinese have a communication satellite going around the moon.
Yeah.
Wow.
Yeah.
Do we?
No, not currently. That's part of the plan. Once we start doing, especially when we do South Polar operations, all that kind of stuff, and want to do a lot of things, we'll have different ways of communicating with people and spacecraft on the backside of the moon. Where,
there is so much more to talk about. I want to.
You can talk forever.
I could definitely talk.
Come on a cruise and we'll have talks about it.
I showed you pictures of my family at the beginning. I want to show a picture of yours because you've had so many honours and awards over the years. But there's a lovely family picture there. Yeah. And can you explain what's the award first of all, and who's who? Okay, so of course I'm in the middle, older and grayer. And this is a NASA Exceptional Achievement Award, and this was I am a founding father, if you will, of the Orion program. I was asked to go to DC, and the first step in any program is writing the contract, the request for proposals for the contract, so you can get a contractor on board. So I went to DC to do that, and was part of the original Orion team. As part of my subsequent responsibilities, there are critical milestones that each program has to go through. And I was the lead for conducting each of those milestones up through the preliminary design review. And basically, this is an award for my work on the preliminary design review of the Orion spacecraft, which we passed with flying colors. So, who's who?
Okay, so on the far left-hand side of that picture is Ellen Ochoa. She was our deputy center director. On the far right-hand side is Mike Coates. She was an astronaut, or I guess it's hard to say. She's not a flying astronaut. She's retired, and so is Mike Coates. He's on the right-hand side, also an astronaut. He was our center director at the time. Then from the left to the right, that's my daughter, Victoria, who's now 27. My wife, Karen, who also supports NASA through a company Booz Allen. She's an engineer. Me and my son, Nicholas, who's now 23 years old and ensign in the Navy. So
that is a lovely, lovely photograph of which you must be very proud. And our next photograph too is of you. Now, the Silver Snoopy Award I mentioned at the very beginning. Can you explain it, please?
Sure. Let's see. The Silver Snoopy is given out to about 1% of the folks that all support NASA. And this is an award given out by astronauts to the worker bees. Okay. You know. And so it's supposed to be for something that you've done that kind of exceptional ensured mission success or safety. I had a friend that got one because he was going through closeout photos of the airlock in a shuttle mission and saw one that showed that they had forgotten to close the equalization valve in the outer hatch of the airlock. That would have been bad.
Yeah.
Yeah, kind of launch with a hole in your system. So he got one for that. Thank you, Richard, for finding that. But and so what this was for, in my case, was I led a team that designed all of the displays that the crew on the ISS uses to control the International Space Station systems. And it turns out that same system can be used in the control center as well, which also enhanced the user interface.
And the person who is pinning the badge on you is Anna Fisher.
That's Anna Fisher.
Yeah, who
at that time we should call her godmother.
Exactly. Yeah. I met her virtually about 8 weeks ago, and that was brilliant too. And that's it, and that's quite something, isn't it? Because it means that you have been valued by the very people you send into space. I think that must be quite something.
Yes.
What
and it's a sterling silver of Snoopy from like the Apollo era, little silver pin, and each one of those is flown, that has been flown on a mission and all that stuff. So it's very nice.
Brilliant. That is brilliant. It must really mean something. What do you say to people? And I know this is a slide that you include in some of your talks. So what do you say to people who say space, it's too much money, and what good has it ever done to any of us? It's just it's a luxury we can't afford. What do you say to them?
Yeah, I've evolved in my explanation to people. The slide you're referring to, bring that up.
It's coming up.
It's a little cartoon that shows technology that has resulted from our going into space. And it's just a little funny thing. And it shows like Velcro, which actually NASA did not develop, but it uses a lot of and kind of made famous, right?
Yeah.
But our ability to talk right now is, of course, right out of the space program. Satellites. I'm sure we're bouncing off a few satellites to be able to talk.
Yeah.
The fact that I'm on a laptop here, the miniaturization of electronics, all that kind of thing, it allowed cell phones to be possible, the smartphones to be possible, all that kind of stuff. We have more technology in our little cell phones than we had going to the moon, right? Which is always amazing, but it's true nonetheless. So these are the kinds of technology things we get. And then as I grow older, I realize a couple of things. I'm reading a book right now, Daniel Borstein's book, The Discoverers. Okay. And, I'm reading about Prince Harry, Henry the Navigator of Portugal. And you think about Portugal was all about exploration back in the day, right? They're the first ones to explore the coast of Africa and learn how to navigate up at least north and south, and do all this exploration. And now they're a beautiful little country, on the western part of Europe, and you don't hear about all the great things in their economy, and it drove their economy. Our frontier in America when we had that, it drove the economy. It drove innovation. Necessity is the mother of invention. Well, as Captain Kirk says, space is final frontier, right? It's where we can go and still push the boundaries of our technology, of our knowledge, and everything else, and improve our economy as a result. Because every piece of technology we develop, we turn into a product that can be used by everyday men and women on Earth. There's not buckets of money being put in the back of a space shuttle and launched to the moon and you don't see it again. The biggest expense for NASA, you see our budget this year, I think it's $22.6 billion. Oh, it's a lot of money. It's not that much. It's 0.5% of the national budget, less than 0.5%. And the biggest expense is personnel, hiring people, providing jobs. All across the country. You can find a map that shows, in fact, NASA just came up with a really recent report showing the economic impact of NASA. And we are in every state and a few countries, okay? And if you think about the International Space Station, the first word is what? International. Same thing's true in Great Britain, in Europe, Japan, Russia, and other countries that are along as well. So
I also think that you and I were I don't know where were you when they landed on the moon?
Decatur, Illinois.
And do you remember it?
Oh yeah. My brother and I stayed up all night long. It seems like we got like 3 hours of sleep the entire Apollo 11 mission, and we stayed up because we didn't want to miss a moment of the whole thing.
You see, that's what I think was important. That's a bond that you and I have, that other kids of not of our generation, they just don't have. We lived through the moon generation.
Exactly.
And so cool.
I was about to get to that. The inspiration for the next generation. Yeah. I didn't really appreciate that until, once again, I got older. Neil deGrasse Tyson talks about how at his museum, they'll have different things and people will come to see their events and all that kind of stuff. He has an astronaut show up, people line up around the block.
I know, it's incredible. And
it's think inspirational.
Yeah.
Most people of my generation, yes, most people of my generation, you ask them, why did you want to work in space or more broadly, go into science and technology? Well, when I was, name your year, there was a guy walking on the moon. Yeah. And I wanted to do that.
Nothing beats going outside. I was saying about my kids. Nothing beats going outside, as I remember I did with my family, in the night sky and looking up at the moon and saying, there are men walking on that moon now. Isn't that incredible?
And all these kids that wanted to do that, obviously, nearly 100% of them never pursued that as an actual career path, right?
But it stays in your heart, doesn't it?
They did academic pursuits. They became scientists, engineers, technologists, mathematicians. In the United States, we call it STEM, science, technology, engineering, mathematics. They all did that. They became doctors, some became lawyers, whatever. But they,
some became
they used this education. They went off to do other things, but they have the fundamental scientific education, and then they applied that in these different things, giving us better technology.
And talking of exploration, before we run out completely of time, your relationship with Viking. I know that you are a sort of, daddy of astronomy on Viking. You've been. In fact, we should have met. We were on the Orion. There you are, the Orion.
There's me. This is before all that, This is us getting on the ship, and that's my wife, Karen.
That's your wife, yeah. Were you excited?
Oh my gosh, yes. I was like, we were so excited, saying finally this NASA thing's paying off, because Anna had invited us. We were friends with Anna, and she had invited us on the naming cruise and the shakedown cruise there. And there's us with Nana.
That's
And
she's the godmother of that.
She is the godmother of the Orion. And of course, the Orion is named after the last program that she worked before she retired, which is our spacecraft.
We are very lucky, and we go on a Viking cruise in the future. You may well be there talking to us about astronomy.
Yes, I'm a Viking resident astronomer now, and it's very exciting, and I get to tell people about this kind of thing and expand on some of the concepts we've been talking about. And I cannot wait so we can start cruising again.
I know. We've just got to be a bit more patient. Okay, I have lots of questions for you. We'll see if we can run through them. Shelton from Silver Spring says, is asking a question about Curiosity. Now, that's a rover, isn't it?
Yeah, on Mars.
On Mars. Right. He says, has Curiosity reached any areas that are impassable? And what do you do to redirect it?
Okay. I'm not really an unmanned guy, but I do read up on it. So what I understand is so far, I've not heard of anything they found impassable because they select their landing sites pretty carefully. And then, and Curiosity is unlike the little bitty rovers. You saw The Martian with Matt Damon, and he goes and finds the Pathfinder. That's a little bitty guy, right? The Curiosity is about SUV sized, and so it can go a lot of places that the little bitty guys can't go. But they have very good cameras, and they survey the landscape, and they take measurements and everything, and they determine. We think we can go down over this area here, and they drive for a little bit. And it's not like driving a rover on the moon like with astronauts where, you can head out. They go a few meters at a time.
What's the time lapse between sending the signal from Earth and being received on Mars?
It all depends on the distance between the two planets. Like right now, in fact, I believe couple of days ago, the two planets were closest approach. And at that time, it's like a 38-minute, I think, time difference between. So you send something out, 38 minutes later it's received, and then 38 minutes out after that, you get the answer. And so they'll send a command. So it'll probably say something like, drive 6 feet, 2 meters. And it'll go, and then it sends back, says, I'm there. And then they go, survey, survey, survey. And they go, okay, go another 2 meters or take a left or miss that big rock or whatever, Now,
you mentioned The Martian. Elise in Malibu, hi there, Elise, says, in these prolonged days of isolation, we are turning to watching more films and documentaries than ever before. Do you have a favorite space-related film or show? We watched October Sky last week, which we really enjoyed. So what's your favorite movie or show about space?
Apollo 13.
Yeah, me too.
It is very well done. Very, very well done. And of course, it's kind of cool to see people that you actually know in real life depicted on the big screen. So that's kind of cool. But and the way Ron Howard did it is he did not shy away from acronyms or just launching people into the environment without. They did a little bit of like the movie thing where they explain what's going on, but a lot of it is just, they're using the lingo, and this is what happened. And it's kind of cool to know some of those people. And if you have just a real quick time for a little anecdote about Jim Lovell.
Oh, please, I love you.
So this last year, was the anniversary of Apollo 11, 50th anniversary of Apollo 11. And of course, this spring was supposed to be the 50th anniversary of Apollo 13. So my son, who's the ensign in the Navy, went to the Naval Academy, class of 2019, and they get these little coins, challenge coins. Military guys know what they are. They also have at the Naval Academy what they call sponsor families. It gives the guys, the midshipmen, a place to go like on the weekend just to crash to get out of the off the yard is what they call it. Okay. Well, turns out that my son's sponsor family, he was a big space buff. And so we said, let's get a copy of Mr. Kranz's book and have him sign it for him, and Nick can give that to him as a gift. And so I'm over at Mr. Kranz's house. I've known Mr. Kranz forever, as shown in that picture.
Yeah, right.
And so we're talking about stuff, and he's showing me, and he survived the big Harvey flood and all this, and he's showing me the house, and he's got this whole collection of challenge coins. Since he's retired, he's gone on a million places to go speak. So I'm like, hey, would you like to get a challenge coin from the Naval Academy class of 2019? I thought a little, giving something back for the book. And so sure. And so fast forward Nick graduates. We have challenge coins. We go. He's home. We go over to see Mr. Kranz to give him the challenge coin. While we're there, we're just chatting away and all this kind of stuff. Phone rings. Mrs. Kranz goes to get the phone. Gene, it's Jim Lovell on the phone. He needs to talk to you for a minute. And Kranz is like, just a second. So he goes, hey, Jim, what are you doing? And they're talking about this Apollo 13 thing coming up, I think. He goes, hey, you never guess what I've got here. Brand new graduate of the Naval Academy. And he hands the phone to my son, Nick. It was like, okay. And so they talk for like 10 minutes on the phone, about just the Naval Academy and Navy stuff or whatever. I don't know. And I'm just sitting there going, how cool is this? Gene Kranz, Jim Lovell. And towards the end of the conversation, my son says, sir, I know I've seen your picture a million times and I know what you look like, but I cannot help but picture you as Tom Hanks right now. And so I just thought that was the coolest thing. And he says goodbye and hands the phone back to Kranz, and they say something. And I'm like, well, he's talking. Well, Mr. Kranz is talking to Lovell. That's like the coolest thing ever.
I'm glad to hear he's still fit and well. That's good. That's good
news.
Felipe in New York City says, have there ever been any spacecraft nuclear powered? And if not, do you think there will one day?
Well, not as a propulsion system, I don't think. There may have been an experimental nuclear propulsion spacecraft I'm not aware of necessarily. I know they've had some on the design boards. There was something back in the 60s. They had a whole program to design a nuclear-powered, booster, which would have been really kind of nasty because it would leave a lot of radioactivity behind. But there are numerous spacecraft that use nuclear energy in the form of radioactive decay with radio isotope thermal generators, is what they call them, like the New Horizons spacecraft, for instance. It's got an RTG on it. It's a big chunk of plutonium that basically gives off heat over time, and that provides electricity for the spacecraft. Any place where the sun isn't going to give you enough power to use solar arrays, something like that is used. And certainly for this advanced lunar exploration that we want to do, it's going to require a lot of power in situ there, and it's probably going to be a space reactor of some sort. But as far as a propulsion system, I don't think so. Now, there are plasma engines that people have developed and ion engines people have developed, and there are spacecraft that use those things, but they're not really nuclear per se.
It's exciting in your field, isn't it? Because it never stops.
Oh, no. It's hard to keep up with. It's hard to keep up with.
It's on and on. What is your son going to do now he's graduated from military college?
Well, he's an ensign in the Navy. He's on a destroyer. He's stationed in Mayport, Florida. So he
doesn't want to be a pilot and then maybe an astronaut or anything.
Nope. Never had an interest in being a pilot. He's got the eyes for it and the physical stuff and all that, but it's never been an interest for his. So he's sailing the blue water.
Yeah, you see, they need a Mars mission to get them, really inspired, don't they?
Go.
We have lots of questions that I think you have already answered in this wonderful talk. I could talk to you all evening, and I'm sure most people watching at home could probably listen to you all evening, but we better let you go. What time is it where you are?
It is about 12 after 1 in the afternoon.
Okay. So we'll let you go for your lunch, and I will meanwhile go and have an evening drink. That's the way it is.
Okay, it sounds like a plan.
I do hope you keep safe and well, and that we see each other maybe very soon, hopefully, on a Viking cruise. And I'll be able to look up into the stars, and you'll be able to tell me which ones they are, and which ones are planets, and which ones are constellations. That would be really cool.
Oh, yes. And right now, there are a lot of good planets out. Mars is as bright as you're going to see it for several more years. Every night, eastern sky. Go look.
It's very definitely pinky, isn't it?
Yes, it's an orangey reddy color. Yeah. So, but it's easy to spot right now. Some years, because we're far away, almost on the opposite side of the sun from each other, then it's just a little dot, and you go, "Oh, that's Mars." It's not very impressive. But right now, it's very close. Sometimes you see on the internet silly articles about how it's going to be as bright as a full moon. Nah, it's not that bright.
Not quite that bright.
But it is rivaling Jupiter right now, and Jupiter's up as well, and Saturn's up.
Well, it's the right time for me to go out and have a look. I'll drag the dog out and have a look.
Exactly.
And do what Tom Hanks did in the movie, put my thumb over the.
That's right. You can blot them all out.
On that.
That's right.
Yeah, it's been wonderful to talk to you. Thank you
It's
so
great
much.
talking to you. Thank you.
And keep safe and well. And I do look forward to the future when we might bump into each other on a Viking ship. And I'll come and attend one of your lectures.
Please do. Oh, yeah. You can attend all of them and the planetarium shows if we're on the Orion or the Jupiter.
Oh, yeah, no, listen, I went and had a look at the planetarium on the top of the Orion. It's absolutely fab, isn't it?
It is. It's really neat. They hold, I think, 26 people. And we have a little show talks about the sky over the ship, and
rest assured, we all know you now, and we'll come up and make ourselves known.
Please do. Please do.
Thank you very much, Charlie. It's been lovely to talk to you. Really.
Thank you for having me.
Thank you very much indeed.
Bye-bye.
Wow, wasn't that lovely? Absolutely smashing here. I promised you somebody fascinating this evening, and wow, did we deliver. Next week on Viking TV, it's a week of what they're saying is history, education and nature at Highclere, and we're going to be showing lots of talks and interviews on some of the most fascinating stories from ancient and modern history. And next Thursday, I'll be telling you about a project that I'm setting up to tell one of the major, I think, untold stories of the men and women who developed radar in the war years, something we all take for granted now, of course, but was unknown some 70 odd years ago, so top secret that no one ever spoke about it then. And so it's still largely an untold story. My parents were very much involved, so I'll be telling you all about them and asking for your insights too. And then the week after that, I'll be back talking to Yo-Yo Ma, the world-renowned cellist. So there's lots coming up to keep you going. Until then, do keep safe and well. So from me and Diamond here in Britain to wherever you are in the world on this wonderful planet, goodbye and good night.